Okay, so I think that's fine. So view, some grid lines. That should be good. All right, so excuse me, my smoothie's not going down. How's everyone doing? Okay, so this is a mess now. I should always do this. No emotions? No feelings about your current state of being? Tired. I feel that. Well, I don't think I need this. Let's get out of here. So we go to files. Tired. Yeah, it's been a tiring few weeks. You guys saw a heat wave in California? We have rain over here. Puerto Rico is getting hammered. Tired. No heat? I heard the governor was asking people to kind of not use electricity. Was that old news? That was last week. That's good. Kind of sucks to kind of sit in the heat without turning on your. Well, I mean, if you want to be a good citizen, you would turn off your AC usage or tone down, anyways. Okay. Anyways, that's good. At least you have somewhat tolerable weather. All right, let's talk about stuff. So today, oh yeah, so incidentally, a few people were having issues with uploading their assignment, so I'm gonna push back the submission window for the assignment until tomorrow. I'm not gonna do that until after class because I don't want people working on it during class, because that's just not a very good tactic. So I will, at the end of class, I'll push back the submission window. You can submit it tomorrow. Make sure it adheres to spec, and then that's that. I'll probably release. I may release the next assignment for this content, although depending on how far we get, I might combine that with next week's material. I don't know. We'll see how far we get. Now, regardless, thank you. What if you've already submitted the assignment? Well, then, I mean, if you already submitted it to mine, then it's already submitted, but the window is going to be open. So whatever that entails is whatever it entails. I'm just going to open up the window. Everything else is... You can do what you want within that window. I'm not going to comment upon that. That's to say, if you can, then, you know, then that just means it's just not some... I'm not paying attention to it. So today we're going to talk about, well, I'm going to discuss in a broad sense some terminology that you're going to encounter in programming, and we'll talk a little bit about what some of these things mean, and how we're going to in part use them moving forward. And then we're going to talk about how we can get our programs to make decisions, because it isn't, you know, it isn't always going to be just linear sequence of instructions. Sometimes we need to kind of change things up depending on various conditions that we meet. And so let's go ahead and introduce some terms, some of which you might know, some of which you might not. So the first term, I'll type this out so I don't make your eyes bleed. Okay, so this is actually general programming concepts in terms. So anyways, so the first word I want to introduce or talk about is this word called algorithms. And so algorithms, there's a bunch of different definitions for it, but one way you can think of it as a well-defined sequence of steps to solve a problem. Now, if you like cooking, if I can spell cooking correctly, it's the same thing, effectively the same thing as a recipe. All right, the steps by which you can cook some food that you like to eat, banana bread or whatever. All right, and so another term that comes up quite often is this idea or this notion of syntax. And so in broad strokes, it's the arrangement of characters or statements or expressions, mathematicals in particular, mathematical, to create, I kind of want the word wrap here, to create well-formed instructions. And so I'm going to put in parentheses in a programming language. And so, comma, in quotes, I'm going to say something the computer, in parentheses, MATLAB, understands. Okay, lots of symbols there. And so that is to say, well, the reason MATLAB is, yes, through MATLAB we're communicating through to the computer to do various things, but the syntax is going to be different between different programming languages, just in small ways. Well, I mean, it could be in large ways depending on the language that you're dealing with. And so, yeah, just be aware that if you once you learn, say, MATLAB, while there will be overlap and similarities, say if you were to go learn Python, Python will have its own nuances that you're going to have to understand in order to effectively communicate the appropriate syntax to the computer. So just, it's kind of like saying there's similarities between, I don't know. Well, no, I was trying to tie things with spoken languages, but it's not that good of an analogy. Or I can say dialects within a particular language, right? And so depending on where you are in a certain country, while the character set might be the same, there's just differences in sort of the way you kind of convey that information through the dialect. So same kind of what I'm saying here with syntax, just different between different programming languages. And so now, primarily, the focus of syntax for you guys, at least getting started with programming, is, well, you're going to encounter mostly syntax errors, right? Because you're going to have mistakes in the way you're communicating to the computer. So this is going to be your primary concern. And so this is, you know, the incorrect, if we kind of invert the statement above, sequence of characters, statements or expressions. All right, and so again, this is kind of like saying the computer doesn't understand, or MATLAB rather, does not understand. And so, in terms of trying to have some examples in spoken language, like I can make the statement, so the through pasture the chase a dog rabbit, right? So there's some grammatical issues. Well, loosely speaking, you can think of syntax as the grammar for computers, and we know that grammar in spoken or written languages is the rules in which we can construct correct statements to convey information, right? And so while this might have the relevant pieces, it's not structured in a way that makes sense. The sequence of these things is not in a way where we can understand what's going on here. So there's a syntax issue here. And then also syntax errors come by way of just spelling errors, right? I could spell a word incorrectly, like maybe this, right? Syntax, what is pisture? I don't know. Also, another example, common example, right? So I ate the taco. All right, so while it might not impede the understanding of what the statement's trying to convey, because humans are very good at sort of overcoming certain things in our own heads, there is still a syntax issue here in that this is not structured appropriately. This is erroneous. And also period. Anyways, so syntax, structure of what you're trying to tell MATLAB. Now, while you'll be struggling with this to a large degree if you're a beginner programmer, like you need to learn the character set or the sequence of character set in order to construct appropriate statements. As you, well, concurrent to this, and as you continue to develop your programming skills, something that's going to plague you throughout this entire time, throughout your entire programming career, is this idea of semantics. All right, this is a bit more difficult to sort of fully pinned down, and it's going to be an issue you're going to, again, have to struggle with throughout your entire career. And effective programmers, I guess, have developed the skills to analyze and to minimize issues with the semantics. So in particular, let's talk about what these means, right? So you can think of this as the meaning, and let me underline this, and I'll bold it too. And why not italics? Okay, so all these things behind, and not everything else. So, okay, just boldment. But I don't want this bold. So the meaning behind otherwise syntactically correct statements. And I think I'm just missing syntactically correct statements. Really? What's the difference here? I'm missing a C. Okay, anyways. So syntactically correct statement. So if you're because, well, if you have a syntax error, it's like a full stop. You can't really move forward. You can't interpret meaning behind statements that are not correct, right? I can't interpret meaning from this. And so once you have a syntactically correct statement, you can then try to understand or try to figure out what is the purpose or the intent behind such statements. And so now, in terms of what you're going to encounter as a programmer is likely the idea of, I don't know why it's bold, semantic errors. Or just semantic. Or we also call these logical. Or error. And so this is effectively, again, if you kind of invert this, it's issues in the meaning or the logic of the otherwise syntactically correct statements. ... All right, expressions or characters and so on. And so, for example, I can have this statement: so the taco ate meat. Structurally, from a grammar standpoint, grammatically, this is correct, right? It has all the sequences correct, and the subject, noun, verb, all those things are correct. But the meaning behind this doesn't really make sense in terms of what we understand these things to represent, right? A taco does not typically have the ability to consume, and certainly we don't have tacos that consume human beings, right? And so there's an inherent issue with how to interpret this. And so now these issues, these semantic issues, come about. So these arise from a disconnect between programmer intent, what it is you intend for any statement to convey, and what the code or the program is actually doing, all right, so that's to say, a lot of times we don't translate our thoughts correctly, and that mistranslation leads to incorrect steps, which will lead to incorrect meaning behind, or even ostensibly the results that you obtain in your programs, right? And so this is what we call bugs, right? So effectively these are typically bugs, period. And so this idea of debugging code or removing these disconnects within your intent and meaning is something that you're going to struggle with for your entire life. And then if you're able to effectively minimize this programmer intent and what the code is actually doing, will reduce the number of bugs that you encounter. And also being able to identify the disconnect will help you identify bugs, which is hard, right? And so this is the reason behind, if you think about any sort of written or composition class, like English composition, have your professors in those classes suggested that you give your papers to someone else to proofread? Has this been recommended to you? Can anyone tell me why? Why did they suggest that? A bug. Well, bugs are anything in which a program behaves different from what you expect. Typically, this is attributed to semantic issues, right? Because after you have something, yeah, you can think of bugs, syntax errors as bugs as well, but they're not the things that plague you, right? And so, broad term semantics fits in. Broad term, but the definition of a bug is syntax error or logical error. Yeah, so I mean, bugs can arise from both locations, but in terms of what you're going to encounter most often, it's issues due to semantics, right? Because when you have a bug report on a program, it's for programs that actually execute, right? So once a program's executing, that's a semantic issue. But yes, you're correct. Bugs can occur from syntax issue as well, but those are not... Well, I mean, I don't know. Maybe at this level, I'm not going to talk about what happens throughout development phases, but yeah. But back to the proofing of your papers. Have your professors suggested that you give your papers to someone else to proof? Not a lot of people haven't taken any or written any papers in class? In any of your classes?
What kind of papers?
Any paper, like a research paper or I don't know, composition paper. So okay, I'll tell you. I'll suggest it now. So when you take any course for which you have to write something, journalism, communication, anything at all, after you or even your emails or statements of purpose, if you're trying to apply to some place, anything that you write, give it to someone else to proofread it. The reason behind that is that you don't. Well, for example, this. Right? How many times have you written, like, say, an email or a text message, and you had these sort of... Well, I mean, these days they have autocorrect, right? But how many times have you seen this occur? Like things like this, like these little mistakes that you have within the things that you write, right? And so the reason that you want to give your reports or whatever to another person is that they don't have an assumption about what is being written, because you assume because you wrote it, you have this underlying assumption that what you wrote is correct, and that typically makes you blind to the issues that come up. For example, things like this. And so, yeah, that's the reason, and that's the thing that you have to develop as a programmer, to be able to effectively strip that assumption away from your thinking, because, and that's to say, any little bit of that disconnect that you have in your mind will result in bugs, right? And so if you're able to remove that from your mind, you'll have less bugs, theoretically speaking, anyways. But does that at least make sense? I don't know. I don't know. I'm trying to think where along in your academic career that you'll encounter this. But even if you don't take a class, I mean, you have to write documentations. Likely you'll have to write documentations, although I'm trying to think of maybe certain career paths that won't have you write anything. I don't know. Or is it this day and age, you guys don't make syntax errors? Or even semantic errors, right? Has anyone ever questioned the things that you wrote? Like, what do you mean? Like, YWM or WYM? Anyways. Any events. This is not an English course. But I'm hoping once you take it, they'll tell you. Well, I mean, grade school. Okay, so the last time you guys wrote reports. That far. Anyways, moving forward. So yeah, so these are just some terms. Let's talk about a few more terms. So what tools do we have available to us to help us develop our algorithms, and also potentially minimize the bugs, minimize the semantic issues that we sort of introduce by virtue of our just interaction with the computer? And so one way is to work in an intermediate medium. Right, and so we have what we understand in terms of, well, if you're a natural English speaker, you think in terms of English, right? You construct your logic in your head as a sequence of events logically, or presumably through that language that you're accustomed to using or that you're fluent in. And it might be that, well, even with professional programmers, even if they know the language well, there's still a disconnect, right? We think in terms of our fluency of language, right? Presumably for me, English. And then while the programming language uses words stemming from English. There's trying to think between the two is still challenging throughout your entire career. And so what we typically work with is a intermediate language we call pseudocode. Pseudocode. And I'm dyslexic. Is it E before U? Pseudocode. So what pseudocode is, in broad strokes, is a hybrid between a natural language and the programming language of interest, right? Whatever you're working in. And so now this programming language, I think, I almost feel like I want to kind of make this more general, because this sort of implies that it's a mix between, say, English and, say, MATLAB specifically, and that's not necessarily true. When we talk about pseudocode, we want it to be kind of a bridge between just talking about, like, just talking to a, well, talking in terms of a, I'm trying to think, how do I state this? I don't want to make it too specific to the programming language, because what I want this to be is I want it to be a sequence of steps that I can use in any programming language, not just, say, MATLAB. And so an analogy of this is, like, say if I'm cooking, like, say, let's say I want to make a soft-boiled egg. Do I necessarily care the brand of pot I use for that purpose? Right? That specific detail, is that a integral component for soft boiling an egg? No, right? It doesn't matter what pot I use. Do I care if I use, I don't know, tap water versus bottled water? Probably not, right? And so instead of saying, in structuring my recipe or my algorithm, instead of saying, I don't know, use, what's a brand of water? Dasani water in a, I don't know, brand of pot. What's a brand? I have to look it up because I don't know brands of cookware. Brands of cookware. Who cooks? Cuisinart, right? I could just say put water in pot, boil pot, and that would let anyone use any pot and any type of water. Do you guys kind of see what I'm saying in terms of making pseudocode not too specific? That is to say, make it general enough where it can apply to any sort of environment that you're trying to implement the algorithm. Does that make sense? And so that's to say, if I create a program to write in MATLAB, it would be nice to be able to also talk about that same program in Python, in Java, in C++, right? So, thumbs up, thumbs down. Am I speaking not an appropriate, understandable language? Shouldn't rely on this. Okay, do you guys understand the intent behind pseudocode? It's actually a big deal. You'll find that when you get into, well, there's actually whole courses based on this. Well, not this specifically and by itself, but when you get into things like software engineering, these tools, these sort of mental tools that we develop, like pseudocode, it becomes integral. And there's standards, some standards that lead into this. So this isn't just fluff on my part. Just know that this is actually an important concept, and it goes a long way to prevent these sort of semantic issues and also syntax issues if you understand how to translate them appropriately. Anyways, let me get a sense of where people are at, because I'm hearing crickets in my head. Well, at least let me get a sense of who's actually present. So 2, 3 people? 4 people? Okay. Alright, just not getting a lot of feedback here, so I'm not sure where this is landing in your heads. And so, so this is effectively a rough outline of our algorithm. Okay, so just so we have a bit of an example, we'll see. We're going to utilize this as much as possible in developing all the programs we write here, but they won't really have their full effect until we write something significant, which we might do at the end of this class. So example. So let's suppose again. So our algorithm here is to solve a problem, right? Steps to solve a problem. So the goal. It's important to understand what your goals are for any particular problem or sub-problem. And so maybe my goal is to, let's go with the soft-boiled egg example. So soft boil an egg. And so let's talk about what goes into this process. So you need to formalize what are your inputs to this program. So let's say I probably need an egg. I probably need some sort of pot. I probably need water. I probably need something to heat it, right? So presumably a stove or any sort of equivalent water boiling facility. And then not only do you want an idea of inputs, you also want an idea of what you're going to generate. So what are your outputs, right? And so sometimes you might have none, and you might have no, depending on what you're trying to do, you might have no inputs, you might have no outputs. So these might be blank, but at the same time, you still need to understand that fact if you do or don't have these, and if you do have them, what are they? And so outputs, well, we're probably going to generate hot water. Whether or not that's relevant is kind of up to us to use, but we will have it. We presumably, hopefully, will have a delicious soft-boiled egg. And then you can get more detailed. Well, so the pseudocode can be used to organize your, or the flowchart can be used to organize your pseudocode. Flowcharts are kind of general tool, and yeah, you could. And then when you get into, again, take a course equivalent to software development or software engineering, there's flowcharts are a big component of that, because the tools that you discuss in those kind of courses are the things that you use to communicate with other developers, right? So things like flowcharts, things like pseudocode, all kinds of diagrams, where it abstracts away the details, which kind of inhibit your ability to understand what's going on and allow you to identify or work within at the level that's important. So here it's important that we have the sequence of events follow in a logical step so that we result in desired outputs. And so a flowchart could fit that purpose. And so, I mean, it could be anything, right? So, and again, with a computer, you have to really be able to break down your thinking into the most minute detail. I'm not going to do that here because it's just going to waste our time. But things like, I could, turn on tap water, right? Place pot under tap water. Fill to, I don't know how much detail, but maybe 2 inches below the brim, and so on. You guys kind of get what I'm moving towards here without going through the entire process. You guys know how to soft boil an egg. Although, I mean, you might not think of it in these terms though, but you have to understand that in order to communicate with a computer, you have to be able to think in these terms. Because otherwise, if you don't, you're effectively projecting your assumptions into your program, which is always bad. So, because a computer can never make use of assumptions, right? It's always going to be incorrect. You might get lucky in terms of your implementation, but you can, the less assumptions you have within your pseudocode, the less it will reflect, well, the less opportunities there will be for you to translate those assumptions into erroneous code. But, I mean, you guys get the point though, right? Do I need to go through this? Because if I do, it's going to be like 50 lines to cook an egg, right? ... Thumbs up? Okay. Well, let me give you guys a time to respond. Okay. I say this though, but I mean, again, I'm assuming I'm projecting my assumptions on you guys, right? But just the point here is, yeah, you do have to be able to break up your thinking into every minute detail. Like even simple things like addition, you might think it's like, oh, I could just tell it to add. It's not that straightforward, right? Because you have to go about it in a certain way, because a computer can't just see numbers and put it together. You have to give it the numbers you want it to add together exactly. So we have an X, and so here, when I go through some examples of an actual program later on, I'll talk about what I mean in terms of how you add in your head is different than how you want to tell the computer to add, because there are steps there that you do automatically that a computer won't be able to understand. Just like here, like we know we put the pot underneath the faucet. We know all this. But again, when we're telling, like, say if you're trying to instruct someone who has never seen a kitchen before, who has never seen a pot, who has never seen tap water, right? That's who you're trying to instruct, in this case, to soft boil an egg, right? They're not going to know any of these. They're not even going to know what a pot is. Just like, this is a pot. This is what you do. And so on. So anyway, so yeah, you're trying to instruct a person who's wholly ignorant of all the things that you're trying to tell them. Like, well, I don't know. Have you ever tried to instruct a child in something somewhat complex? All right, it's a lot like that, because a child has never been exposed to a lot of these things. And so, anyways, moving forward. More things to talk about. Okay, so let's talk about how we can do a few things. Let's talk about control flow. And so this is discussing the manner in which we can manipulate our programs, right? So manipulating the order of events in our program. So and so there's a few ways in which we do this. The primary ones, I don't want to make a table here. So the primary ones, what we're talking about today, so week 4, we're going to talk 4K HD. So week 4, we're talking about branching statements. And then moving forward, I think next week, it might shift, but just week 6, week 5, we might talk about, let's see, this idea of how we can, this idea of iterations or repeat operations. And then week 6, we might talk about how we can use functions to control the flow of information. And then later on, there's also this notion of recursion. I'm not sure when we're going to talk about that, but the recursion is a combination between functions as well as iteration to kind of repeat steps through functions. So that's there as well. And so for today, let's talk about branching statements. And in terms of relevant information for those who are just using this as a programming requirement, this probably covers it, right? So this is common between all languages, and this is what you would encounter as an introduction to anything: Python, C++, Java. These are the things that you deal with. And so if you understand these things, you would have, I'd imagine, cover all the bases in terms of what they expect you to understand from a programming language, to allow you to take other courses that require this information. And so not a whole lot, but we'll talk about all of this and more. Anyways, so branching statements. So it's a way to incorporate, and we'll get to MATLAB in a bit, in your programs. And so let's go through some examples. Well, anyways, before that though, to control the end actions depending on. And so, for example, I could structure some, I mean, this is something that we all use every day in our lives. We make decisions, right? And we, depending on various states of the things involved, you might do something different. For example, so if I am hungry, Hungary. God, I can't type today. Hungary. No, what's going on? Hungry, and it is, I don't know, say 8 o'clock. From the country of Hungary, that's funny. 8 o'clock. I will eat tacos. Otherwise, I will drink water. All right, and so maybe I'm intermittent fasting, and you know, it's. Anyways, who knows? So I mean, we make these kind of decisions in our daily life, right? On almost on a minute by minute basis. We sort of make decisions based on how we feel or what we want to do or what we want to achieve. And so how would I program this? Well, let's see. So let's go through how to encode that example we just went through. So branching. And so it should be no surprise to you that the programming construct that we see being utilized here, or if otherwise, but if else statements are just if statements. Or let me add here, so if. Same thing. When you say if statements, you're also talking about if else statements. Just sometimes you might not have an else clause or an otherwise clause, and so you're just left with an if statement. But same, they're talking about the same thing if you hear those words. And so let's suppose I have a couple variables indicating, say, let's suppose I have a state. I'm going to define a state hungry, and let's set this to be 1, that to represent I am hungry, and let's see 8 o'clock. And so I would say I'll use 0 to represent that it's not 8 o'clock, right? And so the way I would structure a program using this is, for example, let me just copy paste this, because this is more or less pseudocode. Let me make comments out of this. And this kind of goes into here. And then we translate these statements into the equivalent program based on sort of these inputs that I'm providing to this program. And so turns out that the keyword here is if, so if. MATLAB understands if you use if, you want to begin a series of if statements. And so now parentheses to indicate the conditions you want to throw within this if, or for it to check, right? And so if hungry equals 1, if I am hungry, we'll talk about what these symbols mean in a moment, but just know that if I want to check for equivalency, I use double equals. And then I can combine, I can also translate this and using the and operator, or the ampersand, right? So this reflects the and. I can ask another question here. 8 o'clock equals 1, right? To say, that is to say here, let me just state the fact that I'm encoding 1 to be true and 0 to be false. And it turns out that's how most programming languages define true and false. So boom. So if these two things are true, I can display that. Let me just copy paste this. Otherwise, and now so this otherwise is actually else, right? So I could have used else here, but I think otherwise is a bit more elegant when we're talking about spoken languages. So else, otherwise, same thing. I display, I would drink water. Boom. And so we can go through this game where we can, let me execute this, right? We see that we have a missing end statement. And so here, when you see that, it turns out that for most of these control flow constructs, we have to wrap them between if, well, in this case, the if and the end. This else kind of lies in between, but it's an extension of this if statement. And so this end represents the end of the entire construct, right, or the statement. And so boom. This says I will drink water, and this should make sense because it is not 8 o'clock as defined by this particular state, initial state. Whereas if I set this to be it is 8 o'clock, we should expect that this is true and this is true, and so I will eat tacos. And so we see I will eat tacos. Okay, and then you can play all kinds of games with this. Set this to 0. What do I get? I would drink water, right? Okay. So far, so good. Everyone with me so far with this example? I don't have anything to drink. Okay, moving forward. And so, let's talk about the relevant actors that you're going to utilize in order to construct your statements. And so, well, let me get either a thumbs up or a thumbs down or a check mark or X how many of this is new to, or I mean, so thumbs up, you've seen this before. Thumbs down if you have not seen this before. So I can get a sense of where people are at. Okay, a few thumbs down. That's fine. And then people, most everyone else is just like, I'm not going to talk about this at all. Or I'm not going to say. I'm ashamed. Don't be. Do not be ashamed. Or AFK. That's even worse, right? So if you say nothing, I'm assuming you're AFK. And so let's talk about other things. So here you saw me utilize a bunch of symbols. So let's talk more about these symbols and like a fist pound. So here there's this and, it's being sort of encoded by this symbol, and then we have this here, right? This is saying whether or not, you know, this somehow is in capturing or encoding this state of actually being hungry. And so what does it mean to not be hungry, and so on. And so let's talk more on this. So we have relational operators in MATLAB, well, in all programming languages really. And so the first of which is the equal equals, right? So this is asking, comparing whether or not two things are equal. So equal to, right? As opposed to one equals sign. You have to be careful because in some programming languages, they will allow you to do this, right? And so this is doing what? As just what we've seen before. What do you think this is actually trying to do? Instead of asking a question of equivalency, it's resulting in
putting the value 1 in the variable hungry.
Yeah, it's actually assigning 1 to hungry, which is not what we want to do here. And this ends up being a common semantic issue with a lot of beginner programmers, or even, you know, more, what's the word I'm trying to find? Mature programmers? I don't know. Brain's not working today. In any event, so yeah, just be aware that it's a common issue. So if you determine that your code's not behaving the way you expect, you know, you might want to see whether or not you're using the appropriate operators, in particular equal equals. Okay, and so equals to, we have, and so tilde equals is not equal to. What is this? Text messaging? Equal to. And then we have strictly greater than. Ooh. And then there's some formatting that MATLAB or OneNote is sort of injecting here. So strictly greater than. We have strictly, well, greater than and equal to. Please stop. Greater than. Sorry, I'm fighting a migraine, so if I mean I'm sloppy all the time, but more today because of a migraine going on. Makes it hard to see and think. Greater than and equal to. And then we also have less than, strictly, and then less than or equal to. Oh, it's, or sorry, or, and wouldn't result in the appropriate logic. And boom. So these are the relational operators. I'm sure everyone has some understanding, if not from a mathematical standpoint. You've used these logical things in your everyday life in some form at some point, hopefully. Otherwise, it's not a very interesting life. Which, I mean, I don't know. Is a simple life more desirable than a not simple one? Not this class. What class would that be? Anyways, and so there's other operators that you can use, and it depends. Well, I mean, I've been joking with my, joking, but not really joking with my friends about like starting up a farm, like just going out there and just raising, I don't know, beets or whatever. Getting tired of all the craziness. So logical operators relate to logic, and so these are relational or comparison operators. Logical operators are those that consist of, so these symbols, I'll translate them in a moment. So there's this, these are effectively how you can incorporate and, or the logic of anding things. And then there's these guys, which is or. All right, and so let me make a bit of a statement here. All right, so
Professor?
Yes.
Sorry, I didn't understand. So the and the and, like, what's the difference between a single and a double?
I'll state that right now. So single versions allow us to operate on arrays. So I could use it between arrays. We'll go through an example. Arrays, and then, so let me go ahead and how do I want to, double versions only work on scalars or single values or one-dimensional objects or values. Scalars, but allow us, oops, but allow us to utilize short circuit logic. Now this is kind of, I wouldn't fuss over much with the double versions, because the short circuit logic, I mean, while it is useful to incorporate some concise statements, it's not something I'm gonna test you on. But just be aware that that's why there's two of them. And so let's go through some examples. So more branching, and so let's talk about the logical operators. Because the relational ones are pretty straightforward. They're the ones that sort of compare between two things, right? So less than one or greater than one, whatever. So let's go ahead and let me construct a array v1, and let's just make this some values of true and false, right? So let's say true, false, true. It doesn't matter. Whatever this might mean, it might encode just a sequence of states. Something this might represent. And so let me do one more. In fact, you know what? Let me go ahead and incorporate Hungary here. So I'm not hungry right now. Oops. Hungry, because that's something. I don't know what's up with me in Hungary today, or Hungary. It's still pronounced Hungary, but maybe I want to go there. Has anyone been to Hungary? Is the food good? I should. I'm pretty hungry. That's probably a reason. I need a Snickers. So V2, we'll take a break after a while. I'll eat something. And so let's say maybe false, true, false, and then let's say 8 o'clock. I'll copy paste. And so what I can do here is I can say V1 and V2, right? So it combines the two. It's anding the components. So this is the same thing as saying, as well as kind of construct an array. So anding two arrays in this way using the single. Well, you can only use the single and in this case. It's the same thing as grabbing the first component of V1, anding that with the first component of V2. That's the result of the first thing. And let me go ahead and 2 and 2, 3 and 3, and then 4 and 4. And let me make this a little bit larger so it doesn't jump around. 4, 4. So this is effectively anding each component in V1 and V2, and this is the same thing as above. And I don't want it to be code sections, same thing as above. So let me remove the double. Okay, and so just to see the result, right? Oops, missing multiplication.
Oh, Professor semicolon in the line 20, I think.
Oh, yeah. Thank you. Okay, so everything's false, which is fine. If we look at this, right? So this and this is, I mean, we'll talk about truth tables in just a moment, but this is expected, right? So if I make everything, if I am hungry and it is 8 o'clock, let me go ahead and change this. If I am hungry and it is 8 o'clock, I expect this last result will be 1. And so we see it going on here. Boom. All right, so it's just a way to check the logic between two arrays. And then again, you have the same for OR. Now, in terms of the short circuit, so short circuit examples. So let's see. What does it mean to short circuit logic? So let's suppose I'm hungry. I'm not hungry, rather. But let's say, well, let's say it's not 8 o'clock. Although, if we go back to, let me go ahead and grab this. If you go back up to this sort of, this statement here, even without looking at this statement, right? Let's go back up to this. Right, so if I already know I'm not hungry, right? I'm not hungry. Do I care the time? Do I care if it's 8 o'clock?
No.
No, because I'm not hungry, and so I'm certainly not going to eat tacos because I'm not hungry. So it doesn't matter what this is. I could be hungry and it could be 8 o'clock. It's still going to be the same result as, or it could be not hungry and it could be 8 o'clock. Still not going to eat tacos. And so short circuit logic says, well, in this case, I'm going to, because, oops, this is false, right? Because hungry 0 is not 1. I'm not even going to look at this, right? So if the first condition, in this case for and, if the first condition is already false, ignore everything that follows. Right, because it doesn't matter, right? And the value in this is mostly, again, it's nothing that you need to care about. But suppose I have a huge chain of events that follow, right? If I'm anding all of that, whatever that is, This is not what I might have to, well, not appropriate syntax, but whatever it is, it will ignore it because it doesn't matter what that logic is, right? And that's the value behind short circuit. It sort of makes your code a bit more performant in that it sort of stops, it prevents a few steps from occurring. But again, you don't need to worry about that. Boom. Although there's some value in this, in that, well, no, I'm gonna stop it here because I'm not gonna touch you on it. There's some tricks you can play with this to kind of prevent some potential issues that might occur in your code by way of semantical errors. In particular, you might have a condition here that might result in a divide by 0, and then you can kind of prevent that from occurring by checking to see if the denominator is 0 here. I'm not going to talk about it. Ignore all that. Okay, there's a few more logical things that we can talk about here, just things that are not so common in everyday life. There's something called XOR, right? We'll talk about, well, I don't want it to be capitalized. So the XOR, and so in this case, if we have two operands, like two conditions, X and Y, XOR, and it's lowercase, folks, XOR is effectively like an OR logic, but it's exclusive OR logic. Exclusive, I'm off the home row, OR. And so this is saying everything with the OR logic holds true, except if they're the same. And so well, let me go through truth tables for everything in just a second, and we'll talk about it. So just be aware, exclusive OR. And so let me see if I can't state this as one or the other, but not both. Okay. Exclusive OR is one or the other, but not both. And so one last bit of logic here. There's negation. Right, and so that's just the tilde in front of the operator, or the operand, sorry. So negation, or not. And so, for example, if I say, for example, if hungry equals 1, not hungry is 0, right? Not hungry. 0 or not hungry. Relative to the initial state here, right? It flips this, whatever this is, negates it. And so, let me bring up truth tables, and then, well, we'll take a break because I need to eat some beets. So let me throw in a table here. And this is going to be more relevant if you go on to take any sort of class that discusses Boolean logic. So I think a digital logic course might take, or even I think philosophy. If you take anything that has to do with proofs in philosophy, or proofs relating to philosophy, or philosophy relating to proof, you'll talk about these truth tables. Have you guys heard that term before? Sounds all like mysterious. A few people have heard of truth tables. That's fine. Okay, so let me insert a table. And so let me see. Let's do and first. And so I want, let's see, let me count. 4, 3, so 5 and 3. Or rather, so insert. So we want, so the operands, the states, 3, 4 permutations, and then results. Okay, so my operands are going to be x and y. Operands just means the things that are being compared, or the things that are operated on. And so this will be for the and. Right, so that is to say I want to find a result of x and y. Right, so this is, you know, hungry, 8 o'clock or whatever. And so I'm going to go through all possible permutations of these two operands. Right, and so so x can take on the states true, true, false, false, and this will be paired up with ands true, false, true, false. Again, just a permutation of all possible combinations of true and false using two things that I'm dealing with. And so and says, well, this is saying if I'm hungry and it's 8 o'clock, then I go ahead and do whatever I'm doing, right? So true. So if I'm hungry but it's not 8 o'clock, then I don't eat tacos. So this is false. Same thing here, false. And clearly, if I'm not hungry and it's not 8 o'clock, I clearly don't eat tacos, so false. And so one way to remember and, so the shortcut here, and is only true if they are both true. Yeah, so that's the quick and dirty of remembering the logic of and. And this table reflects that. Okay, so I went through that kind of quickly. Is everyone clear on this table? You don't. I'm not going to necessarily test you on the table itself, but you do need to have some understanding of what and means from, well, just from an everyday life standpoint. Like, what does it mean for this to be and this to be true? And you can think of it in these terms, but I believe that if you can think of it in terms of just everyday life, or if you can hash the problem in an example that you can understand in everyday life, you'll be fine, because it's the same logic, right? Actually, it doesn't matter in this case. This can be whatever. If this happens to be arrays, well, no, in this case, they're just single digits. So it doesn't matter which I use in this case. It could be single or double. Because a single only works on arrays, but I can have an array of size 1. Right? Doubles only work on single things. So it doesn't matter in this case. It can be either or. So let me just put both here just to be clear. Either. Okay, so let me go ahead and just copy pasta all of this and do the same thing for or. Symbols are different, obviously. Obviously, as Snape would say. And then here, this is this, and then this autocorrect. And again, I'm sure each of you can, if you sat down and think about it for a while, you can just try to find a situation where you used or in your everyday life. But this is saying, okay, so this or this. Well, certainly, if this is true and this is true, then everything's true. And so this is true. And so now this is saying if this is true but not this, the result will be all still be true, because or picks either one, right? I want to eat this or this. And so the result of which will be me eating something. Same thing here. And then false is if I don't want to eat this, I don't want to eat this, and I don't eat anything, right? So false. So or is only false. So it's a flip statement. Or is only false. Oh. Or is only true if, sorry, they are both true. With, if they are both false. Oh. I guess let me just make clear here, because I've been using the words and maybe might have been sort of, let me say, so x and y are called operands. And operands are just things that are being operated on, right? So things that are being operated on. In this case, through these operators and logical operators and an OR. Let me scroll down a little bit here. Boom. And in this case, the values that x and y can take on are either true or false. The only possible permutations are those that you see here between the two of them. Anyways, moving forward. Boom, boom. Let me just show you the truth table for XOR. Right, so let me just copy this, put this down here. And so XOR, I need to turn off auto capitalization. I'll do that next time around. XY, so it's just the function XOR, and so this is the same thing, XOR. And like I said, it's just like the OR logic, but again, one or the other, but not both. So this is false. So if they're both true, this is a false state. And so again, you likely don't encounter this that all too often, but it's something that's very useful in programming. One or the other, but not both. Let me think. One or the other, but not both. Well, I mean, maybe I'm on a diet, and so I'll eat either tacos or ramen, but not both, right? So that's an XOR logic, mutually exclusive logic there. And so, anyways, that's all I'll say on that. Negation's easy, right? Or date one guy or another. Well, maybe some people are or people, right? And so I'm not gonna judge, but the world is such that such things exist. And so let me just do negations just for completeness. So negation should be pretty straight. Negation only works on one variable. All right, so negation, right? This versus x. And so there's x and not x. So it's a unary operator as opposed to a binary operator. So x is true. And so in this case, it's either false. If x is false, it becomes true. All right, so it just flips the logic. So this is x negation. Anyways. Okay. All this makes sense. You don't have to fuss too much about these symbols as long as you kind of understand on a very high level what all this represents. And if you construct statements in just regular everyday events or language, you should be fine in this and understanding the logical operations that we see here. The tricky thing is how do we put things together to sort of formulate or formalize programs using this. But that just takes time and practice. And after we come back from the break, we're going to go through a example utilizing some of this to do something something you've likely seen before and relatively simple. Well, I say that, but I don't know where you guys may have seen it before. But does that sound like a plan? Well, it certainly is a plan, but everyone good? Are you willing to swallow the pill? Okay, let's take a break. What do you think? 10 minutes?
Can I see the?
Oh.
Can you scroll down the?
Oh yeah.
Yes, thank you.
Okay. Anyway, you guys can catch up on copying this stuff. I'll set the timer for 10 minutes. Eat something. You guys eat something. When we come back, we'll implement solving the quadratic equation. So timer. Or developing a program to solve the quadratic equation. Okay, timer started. After we do that, we'll go through just another type of branching statement, and then we'll just end it at that point. So maybe another. I'm not gonna hazard a guess because if I sort of undercut this, you guys will be like, "Why are you taking so long?" So it's gonna take however long it takes. maybe an hour or more. Let me pause all this.
Recording stopped.
I mean, yeah, this. I mean, if you went to sleep on this, I don't blame you. It's very conceptual. This next part's probably where you want to tune in because we'll go through an example applying a lot of these ideas.